All right, so what we're going to do is we're going to use our inverses that we talked about last unit and use the double angle identities that we've had in the past. So don't forget about your rainbow values. So tan inverse of negative 3 fourths. Okay, just looking at that. Again, inverse trig functions or arc trig functions are always asking for an angle. So this is going to give me an angle. And to kind of give it some familiarity with the double angle stuff, I'm going to just call it A. So tangent inverse of negative 3 fourths. Negative 3 fourths is not on the unit circle, but I can draw a triangle. So that's going to tell us that since we're dealing with tangent inverse, our rainbow values are the side rainbow. This is going to be angle A, and the opposite side is 3, and the adjacent side is 4. Be very careful with your negatives, because if we're going to the right, that's positive, but if we're going down, that's negative. And then if we do our triples, that's 5. So in other words, I can rewrite this as cosine of just 2a. Well, do you know what cosine of 2a is? Well, that's an identity. You have three choices to use. You could do, either one of the three. And here, I'm just going to do cosine squared minus sine squared. So cosine here is 4/5, and I'm going to square that. Sine is negative 3/5, and square that. So we end up getting 16 over 25 minus 9 over 25, which gives us 7 over 25. So again, just using what we've done in the past with our new identities. Well, how can I use my two identities here, or my new ones here? Well, this gives me an angle. I'm just going to call this angle A. So if it's sine inverse and it's positive, then it's in quadrant 1. So this is angle A. The opposite side is 12. The adjacent side, or the hypotenuse, is 13. So the adjacent side is 5. Well, this gives me another brand new triangle. I'm going to call it not A, but B. And since it's cosine and it's positive, I'm just going to draw one in quadrant 1. And the adjacent side is 4. The hypotenuse is 5. So the opposite side is 3. So again, each inverse or arc gives me an angle, and I just called it something familiar so that whenever you see this, it's just sine of A plus B. Do I know an identity for a sum of two angles? Yes. It's SESES. So sine of A, cosine B, same sign, cosine A, sine B. So now we just look at our triangles. Get sine of A is 12/13. Cosine of B is 4/5. Cosine of A is 5/13. And then sine of B is 3/5. So we multiply, get 48 over 65. We multiply those, get 15 over 65. No need to reduce because they're the same denominator. And you end up getting 63 over 65. Done. Again, make sure that you're making sense of this. Sine should never be bigger than 1, so make sure that that's always less than 1. All right, what about this last one here? Well, we have an arc, so this is going to give me an angle. And since we're talking about radians, I'm just going to call it angle x. So since we're talking about arc sine, and arc sine deals with a triangle in quadrant 4 here. So this is my angle x. The opposite side is 3. The hypotenuse is 5. And one of those has to be negative. The hypotenuse can never be negative, so that's going to be negative 3. And then this is 4. So in other words, arc sine of negative 3/5 gives me an angle x. I don't need to know exactly what that angle is. I just can assign it a variable. Wait a minute, that looks familiar. That looks like a cofunction. Secant and cosecant are cofunctions. If I have 90 minus an angle or pi over 2 minus an angle, I end up just getting the cofunction cosecant of x. So cosecant of x is the reciprocal of sine. Sine is negative 3/5, so cosecant would be 5 over negative 3. Doesn't matter where that negative is as long as the negative is there. So again, using the same triangles that we did in the past, just making sure you're using your rainbow values, drawing the triangles in the correct spot, and then finding our new identities. If you have any questions, make sure to bring them to class.